Welcome back to Made in Japan. Last week, I had a few drives fail, destroying my RAID and losing almost all of my data. But no time to cry. I need it back up and running, so let's do some early spring cleaning and rebuild. We'll do a fresh install and reset up my NAS and my Docker containers, then back up my data, host my games, and manage my media. Whether your home lab is on a NUC or an enterprise server, this setup will work for you. Join me as we take a look at my home lab setup and rebuild from scratch. Feel free to follow along. If you haven't already, hit that like and subscribe button so you can be notified of any future videos. I'm sure many viewers are wondering, what is a home lab? Or why do you need a server in your home? A home lab typically refers to a setup where individuals create a miniature version of a data center or network environment in their home. This could involve networking equipment or other hardware to simulate real-world scenarios for learning, testing, or personal projects. There are a few reasons why someone might have a server or a home lab. Having a home lab allows enthusiasts and IT professionals or students to gain hands-on experience in various technologies. It provides a practical and a safe place to test different configurations, softwares, or setups without impacting production environments. Some individuals may use home labs for personal projects, such as hosting their own website, game servers, or running custom applications, like I do. Many IT certifications require practical knowledge, and a home lab is an excellent way to prepare for exams by gaining hands-on experience. Home labs can be used to experiment with home automation systems and IoT devices and smart home technologies. Some individuals, like myself, prefer to host their own services for increased control over data security and privacy, rather than relying on cloud service. You never know where your data is going, and you never know when their service could go down forever. In my case, my server will automatically back up pictures from my family's phones, store them on a redundant storage system, and also upload the images to the cloud for extra safekeeping. This is how I sold having a home server to my wife anyway. Our family pictures are worth more than anything, so she's willing to put up with the cost of my hobby and the space it takes up. I also have Docker containers that run several services that automatically download, sort, and rename 100% legal media. I then use another container to host that media on Plex, so me and my family can watch that media anywhere we go. Sometimes I also spin up containers to host game servers like Minecraft, Palworld, Valheim, etc. Having an always-on computer that I can connect to and use these services is why I started this hobby. It's a great system to learn skills that has helped me in my professional and personal life. My lab originally started out on a Raspberry Pi, but my needs soon outgrew the hardware, so I upgraded using my old gaming desktop. This worked great, but it was a little unstable and used a bit too much power. Since I used the hardware from my old gaming setup, it was about 7 years old and not designed to save on power, so I started having issues. I was then recommended by a friend to check out Yahoo Auctions, where I found cheap used enterprise servers. That's when I met my HP ProLiant DL120 Gen 9. It's a beauty, and at only 10,000 yen, it was a bargain. That's less than $100 US. The CPU only had 6 cores, and it had 16 gigs of RAM, so I purchased a new CPU and 2 more 8 gig DIMMs for a total of 32 gigs of RAM. Now that I've explained my setup, let's get started. This setup should work on just about any hardware, even a Raspberry Pi, although there may be some limitations. I personally have tried this on a NUC, my old gaming PC, and an HP enterprise server. I'll start by logging into my server. Enterprise servers have a thing called BMC, or Baseboard Management Controller. This is like a mini PC inside the PC. Once you set up an IP address, username, and password, it allows you to connect from any web browser on the network. You can then monitor the video output and input commands remotely. It's amazing. Once at our server, we'll start by installing Proxmox from a USB. We'll power up our device and wait for it to give us our boot options. You may need to press a key to get into it. In my case, it's F11. Here we can use our arrows to select the Proxmox USB. It'll boot from the USB and we'll want to choose Graphic Install. It'll take a few seconds to scan the hardware and ready the files, but once it's loaded up, we can choose a drive that we want to install Proxmox on. Next, we'll choose the time zone and keyboard layout, then set up a password and web login. We can also link it to an email so that Proxmox can send you alerts about the server. Next, we'll need to set up the network that our server will be on. Here we can set up a static IP so that it's easy to connect to every time. We'll confirm all our settings and hit finish. Once it's finished installing, we'll need to reboot the server, let it boot up, then we can use the web login from any device on our network. Just open up your favorite web browser, type in that IP address, :8006 for the port number, and we'll be greeted to our Proxmox login screen. Enter in that username and password you set up a moment ago, and we're inside. Congratulations, you now have a hypervisor. A hypervisor, like Proxmox, is a lightweight operating system that acts as a shell, converting whatever hardware you're running into something easily manageable and readable by virtual machines. First, we'll set up a virtual machine for TrueNAS. TrueNAS is an operating system that is very good at organizing data and setting up redundant data pools. First, we'll head over here and use the local disk to import a disk image so we can start installing virtual machines. For TrueNAS, we'll keep most of the settings as default. In the OS tab, we'll select the image we just uploaded, and we'll make a 20 gig drive for the VM. This is just to host the operating system. I like to set it up with 2 cores as it doesn't use very much CPU power. Then we'll give it 10 gigs of RAM. TrueNAS uses ZFS, which is a type of RAID that will use RAM as a cache. So when you upload data to your share, it first uploads to the RAM, which is extremely fast, and then slowly offloads it to whatever storage media you have assigned. This works amazingly for uploading many small files. We'll leave the network as is and finish. Start the VM and it will start booting from the ISO we pointed it to earlier. Select Start Install, and after a moment, we can select Install and Upgrade. Select the boot disk that we set up and tell the system it's okay to wipe this. Select your preferred authentication method. It recommends using admin and just setting a password. Once it's done installing, shut down the virtual machine and remove the ISO CD from the hardware settings. Now that it's done installing, we can pass through our hardware. In my case, my server has a built-in HBA or host bus adapter. HBAs connect your drives to the computer, usually through PCIe ports. My built-in HBA also controls the 2 SATA ports on the motherboard, so I can only pass through half of it and have to manually assign individual drives for the rest. To pass through PCIe devices, we first need to enable virtualization in the BIOS. For the BIOS, we'll need to reboot the entire server. Open the system settings. Once in the BIOS, we will want to make sure that virtualization is turned on. The location and naming may vary depending on your motherboard's maker, but it's usually in advanced settings and called something like Intel Virtualization or SVM mode. Make sure it's enabled. Save your settings and exit. We'll let the server reboot. Once the server is back up, we can log in and connect to the shell. Type in nano/etc/default/grub. Then in the grub cmd line Linux default, in the quotations next to quiet, we want to type Intel_IOMMU equals on. This will allow virtualization inside Proxmox. Control X, yes, and enter to save the file. Then we will need to update grub with update-grub. Once pass-through is working, we need to check what bus ID the device is on. Open up Proxmox shell again, or SSH, and type in this command, udev adm info-q all-n/dev/your drive letter bar grab dev path, and enter. This will show you the PCIe device that drive is connected to. It's worth checking all of the devices that you want to pass through to make sure exactly what bus ID they're on. Sometimes one card may have more than one bus ID, and in my case, we can see that the boot SSDs is on the same bus ID as 4 of my data drives. So passing through the ID for my drives would break Proxmox, and it would no longer have access to its own boot drive. Once we've confirmed our IDs, make sure that TrueNAS is shut down, and we can edit the hardware settings. Go ahead and hit the Add button, add PCIe, click on Raw Device, and search for the IDs we just looked up. Click Add, and we can see our device is now passed through to the VM. If everything worked properly, we can start up the virtual machine and we're good to go. As I mentioned, in my case, I can't pass through my 4 drives that are connected to the same bus as my boot SSD, so we'll pass those hard drives through manually. First, we'll need the drive IDs. We could use the drive letter, but this could change from time to time and would end up causing issues. So it's better to grab the device ID. Confirm the virtual machine is shut down. Open up Proxmox shell or SSH. We'll type in ls-n/dev/disk/byid. This will list all of the drives attached to Proxmox. Once we find the drives, make note of the ID. In my case, it's ATA- the model number and the serial number. Next, once we have a list of the devices that we want to pass through individually, we'll type in /sbin/qm set-virtio, and this is important, the number that this drive will show up as. If you have 10 drives, there'll be Virtio1, Virtio2, Virtio3, etc. /dev/disk/byid/drive ID that we just made a list of. As we hit enter in that command, we'll see the hard disk pass through to the virtual machine in the hardware section. You can confirm the number and the serial numbers against the drives you wanted to pass through and confirm everything looks good. Go ahead and start up TrueNAS, and again, if everything is working properly, it'll boot and all our drives will be available in TrueNAS. To create a pool in TrueNAS, open up your browser and type in the IP address we just set up for TrueNAS. Sign in with the username and password you just created and log in. You'll be greeted to the dashboard where it shows our memory usage, CPU usage, and any pools that we have set up. To create a new pool, go to Storage, Create Pool. We'll create a name for this array. In this example, we'll use Test. Click Next, and here is the array setup. Layout is the redundancy settings for our disk array. Stripe is combining 2 or more disks into a single drive. However, there's no redundancy, so if one drive fails, you lose all the data. Mirror takes even number disks and creates a duplicate, so if you have 2 disks, you'll only have the space of one, while the other has a duplicate of all the data. RAID Z1, 2, and 3, the number indicates the number of drives that can fail before data is lost. With RAID Z3, you could lose 3 full drives without losing any data. For this test, I'll click Stripe, which again is not redundant, so if one drive dies, all data is lost. But I won't be keeping anything important on here anyway. Here it will automatically select all the disks of the same size, or you can select manual selection. You can add a VDEV and drag in your drives that you want to use for this pool. Click Save, I'll click Next. All these other settings are optional, so we won't mess around with them for now. We'll click Save and go to Review, where we'll double check the drives that we have selected and the capacity that it will give us. We'll click Create Pool, confirm that any data on these disks will be deleted in the creation of this pool, and continue. The time it takes will depend on the amount of drives and the storage capacity of those drives. But once it's done, we'll be shifted back to the storage page where we can see all our pools that are currently active. If we scroll down, we can see our test pool with 2 disks at 2 terabytes each for a total of around 4 terabytes. To make this accessible to our containers and other network devices, we'll need to create a datasheet. Go ahead and click on Datasets, go to our test, and add dataset. Test with a capital T is the name of the pool itself, but that will not be accessible by other devices. So we'll have to create a dataset that our devices can connect to. We'll use test with a lowercase t. All these can be left as default, and we'll click Save. Next, we'll need to create a share so that Windows and other devices can connect to our dataset. Go ahead and click Shares, click Add. We'll find the dataset that we just created, lowercase test. We'll leave the permissions as default and click Save. It will then ask us to reset the SMB services if it's already enabled. Then it'll ask us to create access control lists, and we'll create users that can access this data. We'll go ahead and clean everything up and save, and then go back in and add our user. Click Add Item to create a mask. Give it read, write, and execute permissions. Then click Add Item again. Go to User, select our user that we want to be able to access, and give them permissions. Click Save, and now we should be able to access our share from any device on the network. Let's go ahead and give it a test in Windows. Open up this PC or my computer. Click on Computer, map a network drive. We can choose a drive letter, / our IP address, hit Browse, and we should see our TrueNAS options. Go ahead and connect with different credentials. Type in the username and password that we've set up. Our share will then open up a new window, and we can test by creating a new folder or a new text document. And we're good to go. Now we should have permissions on all of our devices using those login credentials. For the Docker server, I like to use Ubuntu. Ubuntu is an extremely popular Linux operating system, so there's a lot of support online, making it easier to deal with problems in the future. Create a new VM, name it something like Docker. Then in the OS tab, we'll select the Ubuntu ISO we have uploaded earlier. For a boot disk, I want something a little larger. Plex can use a lot of space storing metadata and whatnot, but this depends on the amount of media and metadata settings that you have set up. So I'll choose something like 80 gigs. We'll choose here to store the virtual drive on the local VM storage. For CPUs, I usually put 8 cores. This is mainly for gaming servers, but Plex can also use quite a bit on its own. If you don't plan on creating any game servers, you can probably get away with 3 or 4. And we'll set 10 gigs for RAM. We may add more later depending on a use case. The great thing about Proxmox and virtual machines is we can change our hardware settings whenever we want. If we need some extra cores or CPUs, hard drives, or memory, we can just add them to our hardware list, and next time the server restarts, it will be updated with the new hardware. We'll spin up the VM and go through the normal install settings for Ubuntu. Things like language, keyboard, time zones, etc. Here, I like to choose the minimum install, as this is going to be a Docker server and not used as a desktop. I don't need a bunch of extra software. We'll create a user and password and let Ubuntu finish installing. Once it's done, it'll ask us to shut down the VM and remove the CD ISO drive, just like we did in TrueNAS. The first thing I like to do once Ubuntu is finished installing is install OpenSSH server, because copy-paste works much better through a terminal rather than the web browser. First, we'll do sudo apt-get update to update the repositories, then sudo apt install OpenSSH server. Hit enter to confirm the install, and away it goes. After a few seconds, we are good to go. Use your favorite terminal to connect through SSH. I like PuTTY. Next, we'll connect to the shares we made in TrueNAS. The Docker containers will store data on the NAS, so we need Ubuntu to mount these shares when it boots. First, we need to install CIFS drivers, so Ubuntu can connect to SMB shares. So we'll use sudo apt install CIFS utils. Once that's finished installing, we can open up the fs tab using sudo nano/etc/fs tab. Here we will add the information for our share. In my case, my information looks like this, but you will probably need to change the IP address, share name, where you want to mount the share locally, and then of course the username and password. If you're not worried about security, we can put our credentials right in the mount command, but I can't recommend using that long term. It's better to create a reference text file that we can lock and store, as fs tab is easily accessible. If we've entered the right information in our mount command, we should be good to go. Type in sudo mount-a to mount all the services in the fs tab. If it all worked, we will be able to cd into our share and see all the files on the share. It's also good to test out your permissions and see if you can create a directory or file directly on the share. Alright, next let's install Docker. Type in these commands to set up the Docker repo. Then we'll add the repository to the app source. And finally, install Docker. Next, let's create a Portainer container. This will help manage our containers in the future. Use the Portainer commands to create a volume and install the Portainer container. You could change the ports or environments, but I recommend leaving it as is, as this just works. Great, now we can load Portainer on our web browser. Just type in Ubuntu's IP address followed by the port number that we just set up. In my case, 9334. Here we'll create a user profile and we're in. The great thing about Portainer is we can create stacks. This is a text file with all the information to create the Docker containers that we want. Here is the stack I like to use. I'll have a link to a file below. You will need to change some things depending on your setup. Things like ports or volumes, and in some cases passwords and usernames. But that will be noted in the file we link below. Make the changes to work with your system and copy and paste it into your stack. Hit deploy, and after 10 to 20 minutes, your containers should be up and running. But there's some last-minute configurations that need to be done. For example, Plex. In the stack, there's a place for a claim code. The claim code is something that we generate from our Plex account. It expires after about 15 minutes, so it's best to start the container, then go back and change the stack. We'll copy and paste a new claim code and update the stack. We can then log into Plex through the IP address and the port number. Then we will be greeted with the option to claim the server. This will link it to your Plex account, so you can manage it. Here we'll select our libraries where our media will be stored and set up our Plex settings, but that's a whole nother rabbit hole. So next, we'll jump over to our downloader. If we want our downloader to use a VPN, we will need to give the container a location for VPN configs. Let's go back into Ubuntu and download our config files. I use Nord, so I can look up the config files online just by Googling NordVPN config files. Then I'll choose a good connection from the list, download, and save it into our OpenVPN folder under Docker QB-torrent OpenVPN folder. Then restart the container, and we should be able to watch it boot up and connect. If your logs look like this, you should be good to go. We can connect to the web UI by going to the IP address, port 8080, or whatever you set yours up to. The default user is admin, and the default password is admin, so it's important to change those. And we're all set up. Next, let's set up Sonar and Jacket. You know the drill. Open your browser, type in the IP, and the port number you set up. Sonar and Radar are controllers for media management systems, so we'll need to point it to the other programs we've set up in other containers. First, let's go to Settings, and then Download Client. Here we'll choose QB-torrent and enter the information we just set up. Hit Test to confirm it's working. Then next, let's add the pathways to our NAS. In Media Management, we can choose our root folders, and we'll be able to search for the volumes that we set up, which connect to that NAS. It might be a good idea to test out your permissions here by opening up the shell in Portainer. We can go to our container, click this button to access the shell, log in as root, and try making a directory. Next, we need Sonar to be able to grab torrent files from the internet. We can either set this up directly in Sonar by creating a direct link to a site like NyaTorrent, but I prefer to use an indexer like Jacket. Setting it up this way creates a more refined search result, so I don't get junk downloads. To set up a connection to Jacket, we'll go ahead and click New, and the bottom right option, TorsNAB. Here we can name it Jacket, and we'll need the API key. In another tab on our browser, we'll open up Jacket, IP address, and the port we set for it. In the upper right-hand corner of Jacket, we'll see our API key. Go ahead and copy that, bring it back to Sonar, and paste it in. Next, we can set up our categories and settings. For the most part, I only download anime that I own, so I can choose anime in the categories section. I don't have any restrictions on seed ratios, and I haven't had much success with setting tags, but we'll use Jacket to refine those settings a little further. The last part we need here is the URL. So let's go back to Jacket, And we'll add an indexer. In the search bar, we can search for just about any torrenter, even private ones. Again, since I only download anime, I'll choose Nya torrent. We'll choose Nya from the list and then set up its configuration. For me, I like to change it so that it's trusted only and English translated. That way I don't get anime in random languages. And I have it select files from high seeders to low. With these settings, we can go ahead and click OK and click on the copy Tors nav feed. This will give us the URL that we can enter into Sonar. Go ahead and paste it in there and click test. If everything works all right, we'll get the green check mark, can hit save, and we're ready to go. You can add new series at the top, but remember, it's not legal to download anything that you don't already own, so download at your own risk. And that's it. Your home server is set up. Sonar will talk to Jacket to look for your totally legal downloads. Send the request to your VPN-protected downloader and save them to your NAS. And then Plex will pick up the media and host it for you to consume on any of your web devices. You can even set up apps on your phones like PhotoSync to create automated photo backup systems from your phone to the NAS. You can spin up new VMs on Proxmox whenever you want and use them to learn and build skills. Practice using Linux, building network management, or packet tracing. Whatever you like. If you like this content, feel free to let us know down below. Let's make some videos together and enjoy the learning process. See you!